All right, so welcome everyone. Today I thought I'd talk a little bit about the HSDS package and then go over some of the issues, and then we can have whatever discussion our thoughts lead us to. So first, HSDS package. So when HSDS was first developed, it was this Python code that was typically built as a Docker image and run in Docker. And then you could also later develop the ability to run it in a Kubernetes cluster. But, I started thinking, as a convenience, a lot of people may just want to run HSDS as a desktop application. So to do this, we created HSDS package, and I can go to PyPy and show you how that looks. So let me share my screen first. If I can find it. Here, I'll just share the whole desktop. Where am I? Seems like Zoom is taking over everything. Okay, here. You see my browser?
Yes.
Yeah. So if you go to PyPy, PyPy is the Python package repository, and search HSDS, you'll see there's HSDS 0.8.4. And if you go here, there's a description and release history, and so on. So let's walk through how you would install this from scratch. So I have a terminal on my desktop, and I'm using Anaconda, which is a system that lets you create virtual Python environments. That way you can install things without having collisions with other software. So if I do conda create -n, let's call this HSCTD, and we'll use Python 3.9. This will create a new conda environment for me. That takes a little bit time to get set up. Okay, so yes. And now I'll do conda activate HSCTD. So now I'm in a clean new Python environment, and we can do conda install HSDS, and this will get the HSDS package. Maybe I should do a pip install. Let me call this. I usually do pip install. Pip install HSDS. Looks better. So this installs the HSDS package and whatever dependent packages HSDS needs. And while we're here, let's install H5Py. So I'll do conda install H5Py. Alexander would tell me to use condaforge, but for this purpose, it'll be fine. And finally, let's do a pip install H5PyD, which is the Python client package for HSDS. Okay, So now we're all set. We can, if I type HSDS -help, it'll tell me these are some options for running it. If I say, now there are various ways you can set this up to use S3 or Azure, have a password file or not, use Mino data storage. For this talk, we'll just do HSDS running as a POSIX store. And to do that, I need to create a directory. So let's do a make directory HSCTD to go along for a Python package. And now we do HSDS, and the only option we actually need to have is something to tell it where to store the HSDS files. So we say root dir, and you have to give it full path, and we're off. Okay, so it says ready. Using endpoint HTTP ://localhost:5101. Good enough. So let's, if we kill this, that would end our server. So I'm going to open a new terminal. And if we do something like curl HTTP localhost 5101 about, we send a HTTP request to the server and we get a response back. So that's a good sign. Now let's go to the, let's go to the same Python environment I had before. So we do conda activate HSCTD. If I do, so let me talk that in general, you communicate with HSDS by providing a username and password. We didn't explicitly set up any usernames and passwords when we started over here. And if that's the case, HSDS defaults to your user desktop name as your password, and your user desktop name as, your user desktop name as your username, and user desktop name as your password, which is not very secure, but for our purpose, we're just playing around with HSDS and such. In a real production environment, you of course want to have a actual password authentication. So in H5PyD, we can set up the passwords using this hsconfigure tool. So it wants the name of the server endpoint and username and the password. So we can just take these defaults, and it says it's okay. And now we've set up our password credentials file. This is actually a file called .hscfg in your home directory. And now you all know my username is John and my password is John. So now this says up, if we do these h5pyd commands, like hsinfo, we actually get a server name is the default. Server state's ready, endpoint is localhost 5101, username is John, and notice this paren admin. So not only is your desktop name the default username, you're also an admin user of HSDS. And home, no access. So home is actually looking for a folder called /home/John in this case. That doesn't exist, so it says no access. So we can rectify that in a bit. The server version is 0.8.4. That's what we saw in the Python package. Node count is 4. That's the number of DN processes that are running. And it's been up for 2 minutes while I've been talking. So about this home thing, if I do hsls/, there's nothing. If I do htouch, we can create a folder like so. And now we have a home folder. if I do HS touch home John, we now have something at home. And HS info should be happy at this point. Okay, so it says my home folder is /home/John. So now we have a server running. What can we do with it? Well, you could load an HDF file into the server. I happen to have something here called tall.h5. If I do h5ls-r tall.h5, you see that h5 dump -r shows that. And to upload from HDF5 files to a server, there's a tool called hsload. And we'll use the syntax. You don't have to use this, but it's just kind of a way to distinguish local files versus HSDS domains. We can say hsload tall.h5 to the root folder of HSDS. So that ran. And now if I do hsls/, so this is a privilege that only admin users have, which is to create content in the root folder. So normally, if you were a non-admin user, you'd have a folder where you have assigned permissions. For example, if I do hsackle/home/John, it'll say that John has permissions to read and update in the folder. And if I wasn't an admin user and I wasn't John, I wouldn't be able to create any content in that folder. You can do something like hstouch -o Joe Bob, O for owner, home Joe Bob, and hsackle home Joe Bob. Oops. So here, the username is Joe Bob, which doesn't really exist. He has permissions, but a non-admin user would not have permissions to create content in that folder. Anyway, back to our hsload. So we had hsls H5, so that's there. If we do the -r, that's there. If I do hsget, I can pull the domain down from server onto a regular HDF file again. And if I do h5 dump, cd, we've got all the same content that we had when we started with. Okay, so that's just kind of like a quick start guide for HSDS. The intent is to have minimal barriers to getting going. And if you try it and you like it, there's a lot of different directions to go. You can write applications with h5pyd or the RESTful. You can run HSDS in Docker or in Amazon or in Kubernetes, lots of different things. So, but just wanted to minimize the barriers to entry, so to speak. All right, any questions about HSDS as a package? Not?
John,
Yes.
I just have a question. Is there a way to look behind the curtain there when you created the HSDS store on POSIX? Can you just give a quick show of what that looks like?
Right. Yeah, let's do that. So my folder was called HSCTD. And if you look in this, you'll see that so let's say another thing is the root folder, the root directory that you provide to the server is not where things under slash go, because there's a default bucket that's created. Well, they're not really buckets, but they're in POSIX are just extra directories, right? So you have the root directory and you have whatever buckets you want to have. And under the buckets, you have the things you see with HSLS. So if I do like HSLS dash bucket, HSDS test, we see that, right? So this HSDS test is the default bucket for this instance of HSDS. You can organize this with different buckets. For example, I can make a directory HDF2, whatever. And then if I do HSLS -- bucket, HDF2, we see there's a folder there. So that might be useful if you want to organize stuff in these different buckets. There's no way through the REST API to create buckets. That has to be done manually. If you're using something like AWS S3, this translates to the concept of S3 buckets. And again, they would be created by the system administrator, and your privileges to write to them would be set up by your configuration to HSDS. But anyway, back to the question. If we go to this, your original bucket, HDS test, oh, where am I? Call.h5. If we go to there, and it's actually a directory, not a file. And we see there's one thing called .domain.json. If I do that, we see it has a root UUID. It has the owners, John, the ACLs, which I was showing through the HS ACL tool, a created timestamp, and a last modified timestamp. And that's all you have, right? All the data for this HDF5 domain is somewhere else. And that somewhere else is under this folder, special folder called DB. So here you'll have a folder where the subdirectories are basically the first part of the GUID of the root group. And if you go there, you'll see that we have a .group.json and a .info.json. Okay, look here. This is just the metadata for the root group. So there's the UID again, the created timestamp. There are some attributes. There are some links to subgroups and so on. And then if you go under that, say to G for group, we have a bunch of GUIDs again for the different groups in tall.h5. Similarly, for the D, these are all the data sets. And if we go to one of these, it looks pretty much the same. There's a dataset.json. And this has properties like the type, the shape, the layout class, fill value, that kind of thing. And you'll notice there's this thing called 0. That actually is the chunk data for this data set. So here in this data set, there's only one chunk, and it's one-dimensional, so your chunk is 0. if you had 1, 2, 3 for each chunk index. So a couple of things is, why is it that if I back up one, that we don't have so the hierarchy of the original HDF file were things like /G1, /G1.1, /dataset 1.1.1. We don't replicate that hierarchy in the file system. Instead, it's a fixed two-level hierarchy where you have a folder for the root group and then subfolders for each group or dataset under that. And the rationale is that in HDF5, we support multi-linking. So you could have a dataset that has a link from a group and also linked by another group, right? That would be a little bit tricky to replicate in a POSIX directory structure, let alone, say, S3. So instead, we just store everything in this flat hierarchy, and it's the properties of the group that store the links. So if you go back to here, right, this link G1, it's a hard link. It has this ID and created time. So when I need to go to group G1, I read this metadata, or the server does, and it says, okay, group G1 has the ID G blah, blah, blah. And then it knows from the storage system to go to root group folder /G /that ID, and then pull up metadata for G. So that allows you this multi-linking. And another property is that it lets you move the links around without moving the data, right? So let's say I had /G1 /dataset1, then I make a group G2, and then I link dataset1 to G2, and then I remove the link /G1 dataset1. I don't need to move the dataset1 data. I'm just playing around with the links, not doing a massive data move. Same thing for the files themselves, right? So remember how this domain.json is a fairly small piece of JSON. So if I have hsls/, okay, there's tall, and I want to move tall.h5 to my home folder, I could do hsmove /tall.h5/home John. Can't get parent to me. What did I do wrong? Huh. Let me try this. Oh, I think there's a problem because this is in a home folder. Let me try this. Let me do cd. Now hsmove. Do this. We see tall h5. So if I wanted to say rename this, okay. So my point is that we can move the domain around, and when that move happens, nothing actually changed in the storage system except where that .domain.json file was located, right? So all those UIDs stay the same, they're all in their same place. It doesn't really matter for a small domain like this, but if you had, like, say, gigabytes or terabytes of data, that'd be useful to have. Okay, that's probably a longer answer than you wanted, but I thought it might be helpful.
No, that was very good. I appreciate that. And then the data itself, that's pure binary HDF5 data.
Right. So in HSDS, metadata stores JSON, and chunks are stored as binary blobs. Right. So typically, I see like 99% or more of the storage is chunks, and the JSON is a fairly small percentage. So JSON is fairly verbose, compared to storing the metadata as some kind of binary format. But the advantage is, from the programming side, it's easy to work with, and it's readable, right? So if you come looking directly, not through the server, but looking directly at these JSON files, you can make sense out of the content. Okay. Yeah, thanks for the question. That was good. All right. Let's see, Lori, how are we doing on time?
Well, technically 4 minutes.
Okay.
But whatever you'd like.
Okay, let me just do a quick review of some of the issues in HSDS, and then we can come back to them later. Yeah, maybe I'll talk about this one. Support head requests for dataset selection. So this idea is, in HTTP, there are kind of 4 common request types, right? There's get, to get values. There's post, to put data. There's delete, to delete things. And there's put, to create new name resources. There's another less frequently referred to request type called head. And head works just like get, except whereas get would return these HTTP headers followed by the body of the response, head just returns the headers. And you might say, why would I just want the headers and not the actual data I wanted? Well, in this person's use case, what he wants is that there's a certain data selection, and he has reason to think that that data might get updated by some third party. And when it's updated, he wants to fetch the updated data. But if it's not updated, he doesn't want to spend a lot of resources getting a lot of data that hasn't been modified, right? So imagine you have a server running somewhere, you do a regular get, you get maybe a few megabytes of data. If I think that data is going to change, and I had no other means to know if it's changed, I would have to do periodic gets, like every minute do a get. Every minute get another few megabytes of data, and then compare what I got with my previous response. If you had this head request, how it would work is that I would do my first get, and then every minute I could send a head request. And that those HTTP headers would include a checksum, basically, that says, this is a checksum of the response I would have sent you if you had done a real get. And the client now can compare that checksum with what he already has. If the data hasn't changed, the checksum won't change. If the data has changed, the checksum will change. And then next, you can do a get and get the data. So you can kind of keep a synchronized copy locally of whatever selection of whatever data set he might be interested in. I just thought it was a little bit interesting, this use case. All right. Any other questions? If not, I guess we will say goodbye to next time. All right. Hearing no questions, I guess that's it. Lori, any announcements?
So we will be presenting a Birds of a Feather session at SC. I'm trying to grab the link real quick here so I can share it with the group. So they are still looking for people if you have a strong desire to be a part of that Birds of a Feather panel. There will be people to reach out to, Elena or Dana. And I'll drop it in the chat now. And then also, you know, it'd be great if you're there to join us. It's on Wednesday at 5:15 p.m. And other than that, Alex,
will it be online as well as?
I don't think SC is typically like free and available online.
Okay.
Not like us.
No. Okay. Awesome. Okay. Thanks, everyone. Catch you next time.
With Alexander. Thanks. Bye.